Yes, hello students, very good evening to all of you. So today we are going to discuss the MCQs, most expected MCQs for your PU2 examination from the chapter coordination compounds. Okay, so we are almost done with all the chapters, so we are just left with one chapter, that is DNF block, that I'll be doing in the next week most probably. So today we will be focusing on coordination compounds. Okay, so hello Srinivas, very good evening to you. Okay, so we can wait for some time for some students to join. Okay, after that we will be starting. Okay, yes, hi Mahesh, hi Neeru, hi Srinivas, hi Pradeep, good evening, a very good evening to all of you. And I wish that all of you are like preparing really hard for your examinations. You are just few days are left, right my students? So please do not waste any time. Okay, so yes, hi Nitin, very good evening. Neeru, good evening. Yes, so hi Neeru, hi. Okay, so we have a lot of students now. Let us start the class. We will be progressing. Today we have got very easy question, not easy, but yes, this chapter will not be giving you very difficult questions for the board examination. So board level questions we have taken, so you have to sit with a notebook and a pen and quickly solve it and put down in the comment section and give me the answers, right? Okay, so we have so many students live now. Let's get started with the first question, students. So shall we start from the back? Okay, let us start from the first only. So I have almost 60 plus questions. So quickly, 1 minute, one question, we can finish it within 1 hour. Okay, let's get started. A purple compound M has a formula of CONH3 whole 6Cl3. On adding excess of AgNO3 to 1 mole of M produces 2 moles of AgCl. If the secondary valency of cobalt is 6, then the correct formula of the complex will be. This is very simple question. You are getting 2 moles of AgCl. I'll say the secondary valency of cobalt is also given. So Srinivas, you can expect 3 MCQs from coordination chemistry. 3 MCQs will be there. Okay. Yes, Nitin, definitely. Jivit is fine. Okay, so I have already got the answer for first question. So those students who have answered, so you can see you have 2 moles of AgCl, that means 2 chlorine has to be outside, and we have 6 NH3. So I will put 6 NH3 here. Okay, and total, okay, 1 second. Yes, so no, we have 5 NH3 here. Okay, I have 1 chlorine I have to keep inside, then I will have 2 chlorine outside and 1 NH3 outside. Okay, so I think the correct answer, will it be D? No, see, if you keep D, the total coordination number here becomes 7, but here it is said that the secondary valency of cobalt is 6. So we cannot have 7 ligands inside, we can have only 6 ligands inside. So that is why we cannot have 3 chlorine outside also, because if I keep 3 chlorine outside, I will get 3 moles of AgCl. So that is also, so this is also wrong. Okay, here what happens, the secondary valency is not satisfied, so this is wrong. Here also the secondary valency is 9, so this is also wrong. According to me, the correct answer has to be option number C here. Okay, option number C is the correct answer. I hope all of you are getting it. So Srinivas and Pradeep, I hope you have got the answer correct. Let's move to the next question. Which among the following is not a double salt? Very easy question. Yes, which of the following is not a double salt? Is it more salt, potash alum, carnallite, or potassium ferrocyanide? You have to find out which of the following is not a yes. Yes, D is the correct answer. Potassium ferrocyanide is not a double salt. Why? Because it is a coordination complex. Okay, it is a coordination complex. Okay, next we have question number 3. The correct order of the stoichiometries of AgCl formed when AgNO3 in excess is treated with complexes. You are treating with this one and this one respectively, and the coordination number valency of of this compound is 6, okay, then how many numbers of AgCl will be produced? The first compound given is COCl3 6NH3, okay, and here we have COCl3 5NH3, here I have COCl3 4NH3, okay, coordination number is 6 here. Yes. Yes, students, please give me the comments with the question number. With the question number, I want all of you to reply. Please mention with question number. Yes, so you can see here coordination number is 6. So 6 NH3 will be inside, 3 chlorine will be outside, right? So I will get 3 AgCl. So I have this option and this option I can eliminate. Here I have coordination number 6. So I will take 5 NH3 and 1 chlorine. So there will be 2 chlorine outside. So I will get 2 AgCl. So option number B is the correct answer. Okay. Yes. Next question number 4. Which among the following has the highest molar conductivity? Yes, molar conductivity depends on the number of ions. Okay. Molar conductivity depends on number of ions. Where the more number of ions will be produced, there the conductivity will be more. So is it K4FeCN6 or CONH3 whole 6, CONH3 whole 4 SO4 or NiCO4? Yes. Quickly answer, students. Just see the number of ions produced here. Here how many ions will be produced? 4 K plus and 1 complex. So this is 5. Here I will get chlorine 3 chlorine ion and 1 complex, so that is 4. Here I will get 2 ion and here I will get 1 ion. So definitely it has to be option number A here. Okay, more number of ions will be produced, so we will get more number of ions. If ions number is more, then definitely the conduction of electricity or molar conductivity will be more. No, Pradeep, Mr. Artist, Hind, Nitin, all of you have given wrong answer here. See, the number of ions you have to check. Here 4 potassium and 1 complex, so 5 ions are produced. Okay, so it has to be option number A. I hope this is clear. Next, question number 5. The primary and the secondary valency of FeC2O4 whole 3 minus complex are. So primary valency is the oxidation number of Fe and secondary valency is the coordination number of Fe. So what will be the answer here? Is it 3 or 3, 3 and 6, 6 and 3 and 0 and 3? Yes. Let's start here. I want students, I can see many students are there online, but very few are replying the answers. Whether it is correct or wrong, please do reply. Okay, put your answers in the comment section. Right, students? Okay. Mr. Artist, please put with the question number. Nitin, please put with the question number. Yes. So I can see here Fe. Oxidation coordination number is definitely 6 because this is a bidentate ligand. So secondary valency has to be 6. So there is only one option with that one. So it has to be option number B. Okay. Yes. B is the correct answer. Hindu, question answer you have given wrong. It has to be B. Okay. Next, coordination number of central atom or ion is determined by. Coordination number is determined by what? Only by the number of pi bonds. Only both by the number of sigma and pi bonds, only by the number of sigma bonds, by the total number of electrons present in a ligand. This is also very basic question. The coordination number of a ligand depends of a metal and the ligand. So which bond is considered? Sigma bond, pi bond, both sigma and pi bond or not? Yes, C is the correct answer. Nitin has, sorry, Mr. Artist, correct answer here. Number of sigma bonds depends on the coordination number. Pi bonds are not calculated while determining the coordination number. Next, yes, this type of question very simple and will be asked in the exam. IUPAC name of the given compound. So you have K3CrC2O4 whole 3. Yes, who can answer this one? Let me see. So first of all, you can see this is a negative part. Right? Negative part means chromium will end with ATE. Here we have chromium, so I can eliminate this option. Okay. Next, here we have the differences. We can see here it is given trioxalato, trisoxalato, oxalato. There is no tri mentioned. Tri has to be mentioned, so this is wrong. Okay, then here in case of oxalato, tris is not used, so this also is wrong. So option has to be, correct answer has to be option number B. Yes, Pradeep is given correct answer. All of you are given correct answer. Very good. Let's move to the next question. PTNH3 whole 4 Cl2 Br2 complex can show what type of isomerism you will find. So I have PTNH3 whole 4. Okay, I have NH3 whole 4 and Cl2. What type of ligand will it, sorry, isomerism it can show? Hydrated, so there is no water molecule, so no hydration will be there. Can it have ionization? Yes, there can be exchange of bromine and chlorine, right? So there can be ionization isomerism, and yes, you can see here we can have cis and trans here, so it is ionization as well as geometrical. For linkage we need ambidentate ligand, it is not there, okay, and there is no optical isomerism here, so that is also not there. Okay, so correct answer here is option number B. Yes, 8B is correct answer. Yes. Next, possible isomerism in complexes CONH3 whole 2, NO2 whole 3 and CONH3 NO2 is respectively are. So what type of isomerism can be possible in these complexes? Yes, very simple. First of all, when you see, okay, when you see that NO2 is present, it is a ambidentate ligand. So when ambidentate ligand is present, then definitely it will have linkage isomerism. I will eliminate other two, right? Now this one, if you see MA3B3 type, okay, they show two types, that is facial and meridional, and this is type of geometrical isomers. Okay, these are the type of geometrical isomers, so linkage isomerism and geometrical isomerism. Yes, Pradeep is correct here. 9D is the correct answer. Next, this is important question. Okay, this is important question. So remember one thing, before doing this question I'll tell you, if the reactant is cis, okay, you are doing some reaction with the reactant, you will get both trans and cis product. But if this is reactant and this is product, but if the reactant is trans, okay, and if you are doing some reaction, you will get only trans product. Okay, that is the thing that you should be knowing. Okay, note, please note this one. Now in the reaction, so COCl2 NH3 whole plus and Cl minus, we get two isomers of the product are formed. Two isomers are formed means both cis and trans products are formed. Then the initial complex is, means it is asking about the reactant. What should be the reactant? You are getting cis and trans as the product. Okay, then what will be the reactant? See, I am getting the two isomers of the product. You are getting cis and trans as the product, right? If you are getting cis and trans as the product, that means the reactant must be a cis isomer. If cis is there, we will get both trans and cis as the product. Okay, this question you might not be knowing, many of you, so please note down this concept. Next we'll go to question number 11. Which type of complexes show geometrical isomerism? Geometrical isomerism is shown by what? You have to tell MX4 tetrahedral, MX4 square planar, MX2L2 square planar, MX2L2 tetrahedral. Yes, so if you remember, what we have studied is tetrahedral geometry. Will they show isomerism or not? Tetrahedral geometry is like this. You have M ligands like this. Okay, so in tetrahedral geometry what happens? The ligands are at equidistant from the metals. Okay, so if you see this compound from this side, it will look same. If you look from this side, it will look same, right? So that is why tetrahedral molecules do not show geometrical isomerism. So I will eliminate tetrahedral options. Now in square planar, we have what type of geometrical isomerism? Cis and trans. So for having cis and trans, I should have at least two types of ligands. All the ligands are same here, so this is also incorrect. So the correct answer will be option number C. Yes, Very good, Mr. Artist and Pradeep. Geometrical isomers are not there for tetrahedral. Next, question number 12. Just a minute. Yes. Which type of complex does not show geometrical isomerism? Again, a similar question. You have which type of complex does not show. Okay, you see the question whether it is asking show or does not show. So as we have just discussed now, this question should be very easy. This question should be very easy. Yes, very good. Pradeep is fastest here. 12th A. So we have discussed right now tetrahedral will not show any geometrical isomerism. So option number A. Okay. Next, question number 13. Optical active complex is. So what do you mean by optically active compound? The compound, okay, and its mirror images are non-superimposable on each other. Then we can call it as optically active compound. So always remember, if you have trans geometry, okay, trans geometry do not have, are optically inactive. Optically inactive. Okay, so right now you can see this is exactly superimposable on this one. So trans, what I can say, it is optically inactive. Now if I think about optically active compound PT, okay, yes, I will draw like this. Okay, now if I draw its mirror image, it will look like this. So I am just drawing for all of you once so that you can understand. Now you see these two compounds are non-superimposable mirror images on each other. So that is why this one will be optically active. Correct answer is option number B here. Okay. Yes, 13B, all of you are correct. Next, moving to question number 14. So this is very simple. Linkage isomerism arises in a coordination compound containing which type of ligand? Ambidentate ligand, neutral ligand, bidentate ligand and chelating ligand. Yes, let me see who can answer this question. Let me have some water, students. I am very thirsty. Yes, I want all of you to answer this question by that time. Okay. Okay. Yes. Very good, Pradeep. Yes, students, 15th one. Fifteenth B. No, Akash. No. This is, you have one cationic and one anionic entities. You have one cationic and one anionic entities. Okay. Interchange of ligands from here to here. This ligand will come here, this ligand will come here. That is what type of isomerism? No, Pradeep. That is coordination isomerism. See, the type of isomerism arises from the interchange of ligands between the cationic and anionic entities of different metal ions. You have two different metal ions. Okay, here this is metal 1 and this is metal 2. The ligands of metal 1 and metal 2 are exchanging. That is called as coordination entities. Yes, Yashwant has given correct. Salmanj is also correct here. Next, question number 16. The inner orbital complex is. So always remember, whenever inner orbital complex is given, generally we should have a strong field ligand for that. Okay, you should have a strong field ligand for the, for what? For inner orbital complex. So can we find out the answers quickly from here, from this hint? No problem, Pradeep, no problem. Just mark this question. You should read the question properly. Okay. Yes. Atreya, please answer with question number. I will not be able to knowing which one. Yes. 16th A is the correct answer. Strong field ligand. Here it is weak field, weak field, weak field. So eliminate these options. That is directly option number A. Okay. Yes. Next we have question number 17, high spin complex. Okay, so remember again here, if I want high spin, generally I should have weak field ligand. Okay, high spin means what? You should have more unpaired electrons. Okay, and more unpaired electrons will be present if I have a weak field ligand. So can I guess from here which will be a high spin complex? Yes, Gauri is correct here. 17th D, COF6 3 plus. Okay, so COF6 fluorine is a weak field ligand, so that is why we will get. So this is generally, okay, most of the cases you will find, but there will be some exceptions as well, but generally this is the correct thing. Next, the tetrahedral complex is which is the tetrahedral complex. So you know, if coordination number 4 is there, we have two types of geometry, tetrahedral and square planar. Okay, now generally tetrahedral happens if we have weak field ligand, square planar if we have strong field ligand. Again I would like to add the word generally, okay, not every time. So can we guess which one will have tetrahedral complex? Yes, Nitin is correct here. 18 C is the correct answer. Okay, so this one will have DsP2 hybridization and this one will have sp3 hybridization. Okay, so square planar has DsP2 hybridization and tetrahedral has sp3 hybridization. Okay, option number C here. Next, yes, question number 19, square planar complexes. Yes, just now I discussed square planar complex will be which one? Quickly we can answer. Yes, all of you are giving correct answer. Pavan, IDK, Ricky, Gauri, Sharath, Pradeep, YouTube, toxic YouTube channel. Okay, fine. So yes, 19th question I have got answer from Gauri, IDK, Nitin. Yes, NiCN4 is the correct answer. Okay, NiCN4 is the correct answer. Okay, square planar. NiCO4 will have sp3 hybridization. See, I told you generally, okay, but here nickel will have, if you see, nickel is having 3D8 configuration, right? So I have here 1, 2, 3, 4, 5, 6, 7, 8. Okay, now see, if you want, 1 second. Okay, so NiCN4 is ours, right? Oh, okay, sorry. Yes, NiCN4 has a strong field ligand, so nickel 2 plus is there, so there will be this one. And I think, yes, here also D can also be the answer. Okay, 19D is also correct. 1 second. Sorry. Yes, 19D is also correct here. Okay, I will check on this one. Okay, but I think NiCO4 2 plus is also correct. Both A and D can be the answer, but I will check this once. Okay, yes, A I am sure A is there. Okay, D is also, I am thinking it is there, but I want to check this one once again. Okay, I'll put it in the comment section, students, you will check in. Okay, next, complex. So let's not waste time now, we will check. I'll put it in the pinned comment section, you can cross check there. Complex with maximum magnetic moment is, so if I want maximum magnetic moment, I need more number of unpaired electron, more number of unpaired electron. For that I need weak field ligand. Okay, IDK, but here nickel is not having 0 oxidation state. Now nickel is in +2 oxidation state. If you see NiCO4 2 plus was given, right? So nickel is in +2 oxidation state. Yes, so we have here weak field ligand, right? So weak field ligand means more unpaired electrons. So option number C is the correct answer here. Okay, next, question number 21, the incorrect statement about valence bond theory. So we have studied the postulates of valence bond theory, limitations of valence bond theory. So which statement is incorrect? Okay, you have to tell about the incorrect statement. It involves a number of assumptions. It gives a quantitative interpretation of magnetic data. It does not explain the color exhibited by the coordination compounds. It gives a quantitative interpretation of the thermodynamics or kinetic stabilities of the coordination compounds. So yes, which is the incorrect statement here? Incorrect statement here. So if you have this one, please remember, you can be asked like the limitations of VVT also. So it does not give, it has lot of assumptions, that is correct. It does not give, okay, this is wrong, and it also does not give about thermodynamic stability. So which statements are incorrect? 2 and 4. So my answer has to be option number C. Yes, Arthreya has given correct answer. Oh no, Pavan alone has also given, many Gauri, IDK, all of you have given. Okay. Next, we'll go to question number 22. The crystal field theory is an electrostatic model which considers the metal ligand bond to be ionic. Statement 2 given is the crystal field theory considers ligand as point dipoles in case of neutral molecules. Identify the correct statement. Both 1 and 2 are correct, 1 and 2 are incorrect, 1 is correct, 2 is incorrect, 1 is incorrect and 2 is correct. Yes. Kirtana, yes, definitely, but yes, that is not enough because you should practice more questions. Okay, 10 years of PYQs is only having 30 to 40 questions per chapter, so you have to do some more practice as well. Okay, yes. 22A is the correct answer. Okay, 22A is the correct answer. If you see, the first statement is definitely correct. It considers metal and bond to be ionic, and the statement 2 here is it considers neutral ligands, okay, neutral ligands as point dipoles. Okay, both the statements are correct. This you can see in NCERT book, crystal field theory definition part, it is given. Both the statements are correct. Okay, yes, Sharath is correct here, Bharat Shetty is correct here. Next, the degeneracy of d orbitals of isolated gaseous metal is maintained when. So if you have remembered, degeneracy will be there, the diagram, first it becomes like this, okay, and then it goes higher but it still remains degenerate. Degenerate means the energy of all the d orbitals have the same energy, all the d orbitals have same energy. So negative charges of dipole molecules surround the central metal. Spherically symmetrical field of negative charges surrounds the metal. Spherically unsymmetrical field of negative charges surrounds the metal. Non-spherical unsymmetrical field of negative charges surrounds the metal. So if you have seen the diagram properly, here we have written like this, one diagram will be like this. Okay, so what will be the answer here? Yes, 23B Bharat Shetty is correct. Spherically symmetrical field of negative charges surround the metal. So at that time the energy increases, but increases at the same level. Okay, next, in a complex with secondary valence 6, so you have secondary valency 6, that means it is octahedral complex. Okay, the set of d orbitals which experience more repulsion with electrons of ligand. So this is, you can easily understand how the splitting of d orbitals takes place in octahedral complex. Which orbitals have or experience more repulsion? Yes, Kirtana, these many questions if you do, that will be more than enough. Okay, so you know here the orbitals dx square minus y square and dz square faces more repulsion, and that is why their energy rises higher. Okay, so option number A is the correct answer. Next, according to spectrochemical series, the strongest field ligand is. So we have a series where we have arranged the ligands, right? So which is the strongest field ligand here? Is it CO, NH3, H2O or F minus? Yes, Bharat, very good. Option number A is the correct answer. Next, the correct electronic configuration of D4 configuration in a weak field ligand. So, if it is a weak field ligand, what will happen? The splitting will take place lesser. Okay, this value is less. Okay, delta O is a very small value. D4 configuration if you have, so I have 1, 2, 3, right? Because this energy is very less, the fourth electron can easily go here. So, it is what? T2G and this is EG. Okay, so what I will get here? What is the configuration? 26A is correct answer. T2G3, EG1, right? Weak field ligand, splitting is less, so easily the electron will go to the higher orbital level or higher energy level. Yes, A is correct answer. Next, question number 27. The relation between the crystal field splitting energy of octahedral and tetrahedral complex. Yes, this one, what is the relation? What is the relation of this one? Hi Mani, a very good evening. Yes, 27A is the correct answer. Delta T is equal to 4 by 9 delta O. Very good Bharat, IDK, Gauri, Pradeep. Next, question number 28. The shape of the pentacarbonyl iron. So, you have this one, FeCO5. So, if you have, I think, somewhere I have discussed, I don't remember which video, if coordination number is 4, then you have two geometries, square planar, okay, and we have tetrahedral. For coordination number 5, you have trigonal bipyramidal, and for coordination number 6 it is octahedral, right? So here the correct answer has to be option number C. Yes, all of you have given correct. Very good. So 29th question, the number of bridged CO groups in octacarbonyl dicobalt 0. Okay, so the structure is very important, you should be knowing the structure here. So I will draw the structure for you. So please remember, it is like this, CO. So we have octadicarbonyl, means there are 8 CO groups. Okay. Clear? So now if I draw this structure, so what will be the number of bridged ligands? We have here one and here one. So how many bridged ligands are present? 29A. Yes, Bharat, very good. That is the correct answer. Okay. Okay, next question number 30. In black, so this is important question, and let me see if anyone is able to answer this question. Okay, from the very small corner book they have took this question. In black and white photography, the developed film is fixed by washing with hypo solution, which dissolves the undecomposed AgBr to form a complex ion. The formed complex ion is, yes, this is really a very good question. Let me see who can answer this question. Mani, I think according to the model paper that has been released by PU, I think the board exam paper will be little bit on the moderate side, not very easy, but not, yes, very tough will also be not there. Some questions, what I feel is the physical chemistry, right, 4 questions will be there, 3 marker, that will be tougher. That is what I believe, that 4 marker questions from physical chemistry will be little on the tougher side. Yes, 30A. Yashwant, tell me, have you learned this or you have seen from the book? Mohammad, Bharat and Yashwant. I want honest answer. Have you all studied this part? If yes, then really your preparation is very good, I can tell you. But tell me whether you have answered this by your own or you have checked from NCERT. Next, question number 31. In coordination compounds, metal shows dash type of valencies. This is very easy, Werner's theory question. Yes, Anupam, this is for board. Okay, so Yashwant has seen from NCERT. Okay, no problem Yashwant, now you will remember it forever. Okay, Bharat has also seen from NCERT. Yes. Okay, fine. Yes, so now answer this question. This is very direct question. Yes, 31 is B, option number, primary and secondary valencies, that is 32. The primary valencies of the coordination compounds are, okay. So Kirtana is saying, ma'am, I can't solve questions for KSET, but I have learnt lecture also. So Kirtana, start by solving examples, okay. So first start solving examples. Once you understand the concept, you are able to solve the questions examples, then go for the questions. Do not directly go for the I can say PYQs or questions. First try to solve examples, okay. Yes, primary valencies of the coordination compounds are ionizable and satisfied by negative ions, right? Yes, option number A is the correct answer. Next, question number 33. Secondary valency of the coordination compound is equal to oxidation number, coordination number, ions in the solution, none of these. Yes, 32A, all of you are correct. Yashwant, Mani, Sharat, Varshu, Bharat, Mani, Atreya. Yes, all are correct. Very good, students. I can find a huge participation today. Yes, so now can you answer this one? Secondary valency of coordination compounds is equal to, yes, coordination number. Very good. 33 is B. Oxidation number is what? Primary valency. Okay, nothing much to explain here. Next, question number 34. The complex COCl3,4NH3 is treated with excess of AgNO3 solution. 1 mole of AgCl is precipitated. The primary and the secondary valency of this complex is. So first of all, you have to draw the structure of the complex, right? Yes. So if I want to draw the structure of the complex, you can see here we have how much? I have only 1 mole of AgCl, so I have to keep 1 mole, 1 AgCl outside. So I have CONH3 whole 4 and Cl2Cl. Okay. Now if you see, this 1 mole of AgCl will be precipitated. Then what will happen? Secondary valency of the complex. So what is the secondary valency? Definitely it has to be 6. So you have to see the order, primary and secondary. So the second option has to be secondary valency. So if you see here, this is given, it is told that primary valency is 6. So these two options we can eliminate. Okay, be very careful here. So either this or this. Now if I want to calculate the oxidation number, this is X, NH3 is 0, this is -2, this is -1, equal to 0. So X will be equal to +3, right? So which is the correct answer? Option number D here. Yes. 34. Pradeep and Pawan have given correct answer. Next, question number 35. The ions or molecules bound to the central atom or ion in the coordination entity are called as. What are the ions or molecules bound to the central atom called as? Yes, this is very simple question. Direct definition base. Is it ligands, coordination entities, coordination spheres, or Lewis acids? Yes, very good Pradeep. 35A, it is ligands. Next, in a coordination entity, the central metal atom or ion acts as a Lewis base, Arrhenius base, Lowry-Bronsted acid, or Lewis acid. So if you see here, metal is there and ligand is there, right? Ligand is donating electrons, metal is accepting electrons. So what is the species which accepts electron? Is it a Lewis acid or it is a Lewis base? So I have given you option, it is not B and C. Is it Lewis base or it is Lewis acid? Yes, very good. D is the correct answer. D is the correct answer. So the species which accepts electron is called as Lewis acid, and the one which donates electron is called as Lewis base. Okay, clear? Yes, very good. Option no, Bharat, it is not A, it is D. Okay. Next, when a ligand is bound to a metal ion through its several donor atoms, the ligand is said to be. Several donor atoms are there in the ligand. So is it a monodentate, didentate, polydentate, or none of these? Definitely Pratham, I will collect all the give reason type questions for organic chemistry and will make a video. Okay, very soon I'll be doing that. Fine. 37C, yes, polydentate ligand is the correct answer, because when we the denticity, right, the number of ligands that is present, it will be more here. Next, polydentate ligand uses 2 or more donor atoms simultaneously to bind a single metal atom is said to be. Ambidentate ligand, chelate ligand, didentate ligand, all of this. Very important question. Polydentate ligand uses 2 or more atoms simultaneously to bind a single metal atom is said to be. 2 or more atoms simultaneously. Is it ambidentate? Many of you are answering ambidentate. Please read the question properly. Yes, students, why are you not mentioning the question number? I am not able to find the question number. Yes, all of these, no. No, it is chelating ligand. See, in ambidentate ligand, it is not 2 or more. In ambidentate ligand, it is not simultaneously. In ambidentate ligand, it is not simultaneously. So definitely this is not there. If this is not there, then this cannot be there. Now 2 or more is given, right? Then didentate is only 2. It is not 2 or more. So that is why this is also incorrect. So option has to be B here. Yes, B is the correct answer. Next, ligand which has 2 different donor atoms and either of the 2 ligates in the complex is called as. It has 2 donor atoms, but either of the 2 binds to the metal atom. Yes, Teju, what happened? Any doubt? Please put down. Yes, so is it ambidentate ligand, chelate ligand, didentate ligand or monodentate ligand? 2 donor site, but one, either of the 2 will ligate. Yes, very good Bharat. Bharat 40A, correct answer. Yes, that is what when, so examples of ambidentate ligand we have CN, either C can bind or N can bind, both will not bind. Similarly, if you have NO2, either nitrogen will bind or oxygen will bind, both will not bind at the same time, right? Yes, 39 is A. 40th question, in the complex FeC2O4 whole 3 minus, the coordination number of Fe is. This is also, I can say, a bit tricky question, but the way you people are answering, I think all of you will give correct answer here. What is the coordination number of Fe? Is it 3, 4, 2 or 6? So be very careful, coordination number is being asked. Yes, Pradeep, Mani, IDK has given. IDK, wrong answer. It is 6. See, if I draw Fe, C2O4 is like this. I am just drawing like this to denote the structure, okay, because oxygen is the donating group. So I have 3 C2O4 and each C2O4 has 2 oxygens, right? So this one will be there, this one will be there, and we will have like this, okay. So now you can see this Fe is having how many bonds? 1, 2, 3, 4, 5 and 6. 3 ligands but 6 bonds. So coordination number has to be 6 here. Okay. Yes, 40D is the correct answer. Next, the oxidation number of copper in the following compound. Very easy question. Just you have to calculate without pen and paper. I want all of you do and answer me the oxidation number. So is it +1, +4, +2 or +3? Yes, quick students. 41B, no Pradeep. Gauri is correct here, 41A. So you can see x minus 4 is equal to -3. So x has to be +1, right? Option number A here. Next, question number 42. Which of the following is a homoleptic complex? Very simple example, very simple question. Homoleptic means all the ligands attached to a metal should be same. So which is a homoleptic complex? Yes, can you answer here? This bracket is not there, okay? This is not there. Yes. Yes, Pradeep, Varshu, Manjeshwar, Akash, all of you have given correct. Let's move to the next question. Yes, Bharat, very good. Option number A is the correct answer. Okay, you can see here all the ammonia ligands are there. Okay. Next, moving to question number 43. IUPAC name of the given compound. Yes, so they do this question properly by taking time. So you have tetraamine, aqua. Okay, so first of all you see the complex and try to eliminate the options. Okay. So first of all you can see that this cobalt is in the cation part, right? So it won't end with ATE. So here I can say ATE, I will eliminate this option. Here I can find ATE, I will eliminate this option. Here also I am finding ATE, so I will eliminate this option. So directly my answer has to be option number B, if there is no error in the typing. Okay. Yes, very good Anupam. 43B is the correct answer. That is option number B. So tetraamine, okay, then you have aqua, then you have chlorido, cobalt, and oxidation state is +3, and then after that chloride. Okay, fine. Next, question number 44. The formula of the coordination compound. So now the formula is given and you have to find the structure of the compound. The formula of the coordination compound tetraamine diaqua cobalt chloride. Yes, so first of all eliminate the options. Here you can see we have 2H2O, like this it is not mentioned inside the compound, so eliminate these two. Okay, next you have tetraamine. Okay, tetraamine is there and diaqua is there. I think there is some error in the question. I think this has to be, I'm changing this option. Okay, this has to be 2. Yes. No, sorry, here I will change the option. Sorry students, this option is a bit wrong. Sorry. So this has to be option number. So I think all of you will know, but this is H2O 2. Just a minute. I will correct it. This is H2O 2. Okay. So yes, definitely the option number has to be the first one, diaqua, and you can see cobalt +3 will come. It will cross multiply this side and we will get COCl3. Yes. Yes students, question is error here. Question is error, I agree. Okay, but option has to be A. Okay, by chloride if I say, it has to be option number A. Okay, so really sorry. Next question, geometrical isomerism arises in homoleptic complexes, cationic complexes, anionic complexes, or heteroleptic complexes. Yes, this is very easy question. Yes, 45D is correct answer. Heteroleptic complex is the correct answer. Very good students, very good. Next, question number 46 here. Geometrical isomers generally found with coordination number, okay, 4 and 6, 2 and 4, 3 and 6, 2 and 6. In which case we can generally find geometrical isomers. So you know in coordination number 4 we will have cis and trans, and in coordination number 6 we will have cis and trans. So the correct answer for this question will be option number A. Okay. Next, square planar complex of the type MABXL show 3 isomers. Among them, this is important question. Okay, this is very important question. Among them we have 2 cis and 1 trans, 1 cis and 2 trans, all 3 are cis and all 3 are trans. So if you have remember, we can draw like this. Okay, MAX, okay, and L. Then you can have M, A, X, B and L. And here we can have M, A, X went BL, then I can put L here, okay, and I have B and X. So here what happens, generally A and X are of one type of ligand, means they can be halogens or they can be some similar type of ligand. So here they are trans, here they are cis and here they are cis. So we have one trans and two cis, okay. So that is your option number A. Yes, very good. Yes. Next, question number 48. Geometrical isomers is not possible for square planar complexes, octahedral complexes, tetrahedral complexes or all of these. Yes, here all of these is the correct answer. Tetrahedral complex is the correct answer. Option number C. Yes, C is the correct answer. Okay, just now we have discussed tetrahedral is not there. In facial isomer of the octahedral complex of the type MA3B3, three donor atoms of the same ligands occupy adjacent positions at corners of an octahedral face. Three donor atoms of the same ligands occupy opposite positions at the corners of the octahedral face. The three donor atoms of the same ligands occupy meridian of the octahedron. So definitely facial is there, means it cannot occupy meridian, so we can eliminate this one. All of this is not possible, so we can eliminate this one. Now if you remember, if you have this type of thing, okay, so this one and this one, okay, these three are, if these three are occupied, that is called facial. So what are they? They are the three donor atoms of the same ligands occupy adjacent positions at the corners, okay, adjacent positions at the corner. So A is the correct answer. Yes, definitely. Next we'll move to 50th question. Linkage isomerism arises in a coordination compound containing. Yes, very simple question. We have discussed this question. Yes, students, quickly answer this one. Pratiksha, good evening. You were. Yes, 50D is the correct answer. Ambidentate ligand discussed. Next, coordination isomerism arises when interchange of ligands between cationic and anionic entities of different metal atoms present in a complex, interchange of ligands between the cationic complexes, interchange of ligands between anionic complexes, interchange of ligands between cationic complex and anionic complex present in different complexes. Yes, interchange of, so these two all of you can eliminate, right? So is it A or D? Yes, A is the correct answer. So this is one coordination and this is one compound, okay. Here we have metal, ligand, ligand 1, ligand 2. Exchange takes place here, okay. Yes, A is the correct answer. Interchange of ligands between the cationic and anionic entities of different metals ion present in a complex. Now see, this is one whole complex, okay. This is one coordination complex. Clear? Yes. Students, any doubt here? Please post it. Is it clear to everyone? Is it clear to everyone? Do let me know. Okay, there is, I can find some students having doubt in this question between A and D. It has to be A, students. This is one particular complex, okay. This is one particular complex, right? Next, the isomers, this one and this one are the example of. What type of example will you find here? Yes, what type of examples are these? What type of isomers are these? Yes. These are your ionization isomers, right? You will get different ions on isomerization, on dissolving in water. According to VBT, sp3d2 hybridization is found in. So you can see this is outer orbital complex. So you will have in case of weak filled ligand. Okay. So here though you cannot find because their coordination number is 4. In coordination number 6, we need weak filled ligand. So option number A is the correct answer. Yes. Next, question number 54, the geometry and the magnetic property of NiCO4. Okay, NiCO4 geometry, if you see, it is, can you answer this one? First of all, if you see NiCO4, its oxidation state is 0, right? So it is having 3D8 4S2. Okay, so you have like this 1, 2, 3, 4, 5, 6, 7, 8, and these 2 electrons are, due to the cobalt is having a strong field ligand, it will pair up here, right? So we will get sp3 hybridization and there will be no unpaired electron. So sp3 hybridization means it is tetrahedral and diamagnetic, option number A here. Okay, yes. Next, we'll move to question number 55. Valence bond theory is limited due to. So what are the limitations of valence bond theory? It does not give quantitative interpretation of magnetic data. It does not explain the color exhibited by the coordination compounds. Does not distinguish between weak and strong ligands. So by reading the options, we all know all of them are correct. Means all of them are the limitations. So option number D, that is all of this. Okay. Next, question number 56. The crystal field theory is an electrostatic model which considers the metal ligand bond to be. We have discussed a similar question. Is it ionic, covalent, coordinate, or all of this? So crystal field theory considers that metal ligand bond is ionic. Okay, because it is not. So the limitation of CFT is that it does not consider the covalent nature of metal ligand bonding. Okay. Next, we'll go to 57. In CFT, ligands are treated as point charges in anionic ligands and point dipoles in neutral ligands. Okay, so this both A and B and none of this. So I have discussed already. If neutral molecule is there, it is a point dipole. If it is a negative charge is there, then it is a point charge. Okay, so it is option number C, that is both A and B. Okay. Yes, all of you are giving correct answer here. Next, question number 58. In octahedral complexes, T2G set orbitals have. So if you have remember, d orbitals are there. When octahedrals come, there is a splitting, right? T2G is at the bottom, Eg is at the top. So lesser energy than Eg set, more energy than Eg set, same energy than Eg set, all of this. So if you have seen, T2G will be at the lower level, so it is lesser energy than Eg set orbitals. Yes, very good. Okay, next question number, so here is a small mistake. This is question number 59. Okay, in octahedral complexes, if delta O is less than P, the fourth electron enters. Okay, so delta O is less means it is a weak filled ligand. Okay, the delta O gap is very less. So Eg orbital to give T2G3 and Eg1 configuration enters into T2G orbital to give T2G4 configuration, both A and B and none of this. So it won't happen, both A and B and none of this will not take place. Now as I told you, because delta O is less, that means what? You have this energy gap is very small. Okay, now we have D4 electrons, 1, 2, 3, and the fourth electron, because the gap is very less, can go to the higher level. So we will get T2G3 Eg1. So option number A is the correct answer here. Okay, yes, all of you are correct. Very good, students. Next, question number 60. Ligands for which delta O is greater than P. are weak field ligands and form high spin complexes, strong field ligands and form low spin complexes, weak field ligands and form low spin complexes, strong field ligands and form high spin complexes. So if you remember, delta O is greater than P, that means the splitting is very high, okay, very high splitting. So that means what? The electrons will start pairing, okay. If the electrons will be start pairing, number of unpaired electrons will be less. Number of unpaired electrons will be less means the magnetic moment or the spin number will be less. So definitely it will form a low spin complex. Now, so low spin complex will be forming here, so we can eliminate these two options. Now the splitting will be high when we have strong field ligands. So they will have strong field ligands and low spin complex. So option number B is the correct answer. Yes, all of you are giving correct answer here. Next, move to question number 61. In tetrahedral complexes, the T2 orbitals have same energy compared to E, lesser energy compared to E, more energy compared to E, and none of these. So in tetrahedral, the splitting is just opposite to that of d orbital in the octahedral. In octahedral, T2g is below, Eg is higher. In tetrahedral, E is below, T2 is higher, right? So in octahedral complexes, the T2 orbitals have more energy than E orbitals, right? If you remember, it is like this, E here and T2 here, right? So T2 have more energy than E. So option number C is the correct answer. Yes, Akash, Gauri, Chandan, all of you are correct here. Next, during the splitting of d orbitals in octahedral complexes, the energy of T2g orbitals is. So if you remember, first of all, T2g is below, right? So its energy will decrease. So eliminate these two options. Okay, we will eliminate. Now what will happen? Is it by 3/5 delta O or 2/5 delta O? So if you remember, it is 2/5 delta O, right? The diagram, if you remember, it is like this. Okay, so this is the barycenter. Here it is 2/5 and minus 2/5, and here it is plus 3/5 delta O. So that is decreases by 2/5 delta O. Okay. Yes, all of you are correct here. Very good. Next, question number 63. The crystal field theory attributes the color of the coordination compounds by DD transition, PD transition, SP transition, and PP transition. So if you remember, all of you, what happens? The color of the coordination compounds is due to the presence of unpaired electrons. These unpaired electrons undergo transition, right? And that is why we get a colored compound. So it is due to DD transition, option number A here. Yes. Next, Gauri, we have just 7 more questions. Okay, so total questions are 70. The oxidation state of metal in metal carbonyl complex is. So generally in metal carbonyl complex, the oxidation state of metal. So you can find many example. You have NiCO4, you have FeCO5, right? So what is the oxidation state of metal here? So if you see, is it 1, 2, 3 or 0? The metal oxidation state are generally 0 with metal carbonyls. Okay. Yes. Next, moving to question number 65, the metal carbon bond in metal carbonyl possess sigma character, both sigma and here it is a pi character, okay, pi character and neither sigma or nor pi character. So if you remember metal carbonyl bond, there is a sigma bond as well as there is a pi bond. This is called as synergic effect, right, or synergic effect is there. So both sigma and pi bond, so option number C here, okay. Yes, 65 B is correct. Okay, so here is a small error. Sorry, this is option number B, this is option number C. Okay, sorry, so this is some typing mistake. Okay, but the second option here. Okay, I hope all of you are correct. Yes. Next, the bond between CO and metal in metal carbonyls is stronger due to. So what is the consequence of that synergic effect? The metal bonds become stronger because of sigma and pi bond. So synergic effect, ligand effect, sigma bond effect, or none of these. Okay, so as we just discussed, because of a sigma bond, a pi bond, there is a double bond created between them, that is called a synergic effect. That is why the bond is very strong. So option number A is the correct answer. Next, which of the following sequence is the correct regarding the field strength of ligand as per the spectrochemical series? So we know the weakest one, I think the weakest one is F minus, I think, and the strongest one is definitely CO. So I can eliminate these two options. Okay, now I think that F minus is the weakest one, so the correct answer should be option number B here, right? Pradeep is saying A, Gauri is saying B. I also believe it is B. So F minus is the weakest ligand, right? Yes. Okay, next we have 68. The number of stereoisomers exhibited by COEN2 whole to Cl2. So when it is saying stereoisomers, it includes geometrical isomers as well as optical isomers. Okay, so you have to think in that way. Geometrical plus optical you have to add and you have to answer. Is it 2, 5, 3 or 4? Two, 5, 3 or 4. So if you see here, COEN2 Cl2, the structure is like this. Okay, I am just drawing quickly. This is the transform. I can draw the cis one as well. Okay, sorry, it should be like this, right? Yes. Okay, so this is the cis form. Now here what will happen, you will have a mirror image of this one, that is like this. Okay, and we have like this, we have like this and like this. Okay, so now you see here, this is the trans, this is the cis, and it is the optical isomer of cis. So total we will have 3 here. Okay, okay, option number C. Okay, 68 is C. Anupam is saying SCN is less than F. Okay, Anupam, I will check it. Let me check one minute. Okay, just give me 1 second. Okay, okay. So students, here is a small error. Okay, yes, Anupam is correct here. So please correct it. SCN is less than F minus. Okay, my bad, I forgot the spectrochemical series. Sorry students, so it is option number A here. Okay, fine. Let's move to the second last question. Addition of excess of AgNO3 to an aqueous solution of 1 mole of PdCl2.4NH3 gives 2 moles of AgCl. The conductivity of this solution corresponds to. So this is also important question. Okay, so when you say the conductivity of this electrode corresponds to, it is like how many cation to anion ratio will come. Okay, so if it is having 2 Cl outside, means 2 Cl will be definitely outside, because we are getting what? We are getting 2 moles of AgCl. So this must be the structure, or I can write this must be in this form, right? This must be in this form. See, 2 plus and Cl minus. So after there is a crisscross, we will get this compound. So the electrolyte is of like, you will get 1 cation and 2 anions, right? So it is a 1,2 type electrolyte. Okay, 1 cation plus 2 anions. So option number C is the correct answer. Yes. 16 Gauri, it is not 1:3, it is 1:2 type. Okay, you have to see the number of cations to anion ratio. 1 cation and 2 anion. So 1:2 ratio. Next, which among the following is the strongest ligand according to the spectrochemical series? Yes, very easy question. So yes, which is the strongest ligand? I hope all of you can answer this question. Okay. Yes, students, last question. Very good. C is the correct answer. And with that, our session has ended. we have solved all the questions, and I am very happy that many of you are very active today. So students, keep this josh high till your exam. Study every day, put all your efforts at this point of time. You know, this last few days really matter. So if you need any help from my side, do put down in the comment section. I will be. So I got a today request like, ma'am, please prepare that reason based questions from organic chemistry. So that is noted. I will definitely make it. So any other help, any other suggestion, any other thing that you want to share, please let me know. I'll be there with you forever, like for till the exams. Okay, so yes, that's all students. And yes, Pradeep, thank you so much. Yes, Anupam, Chakravyuh, you please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section. This PDF will be provided to you. Okay, so students, how was the session today? How was the session today? Please tell me. I enjoyed a lot because I can find a lot of students today active. Yes, Chandan, DNF block will be coming on Monday or Tuesday. Okay, very soon DNF block. One last chapter is left. We will definitely be doing it. Yes, thank you, Salman. Thank you so much. Yes, Varshu, organic chemistry we have already done. Long we started with organic chemistry. You can watch the sessions. They are there in the YouTube channel. Yes, thank you, Pradeep. Thank you so much. I really enjoyed today with so many students. Still, Soumya, I'm an organic chemistry. Soumya, what in organic chemistry you need, can you specify? Because I have made videos on name reactions. I have made videos on like the complete organic chemistry is there. 2 markers, 3 markers, 1 marker, everything is there. What else you need, do let me know. I have done a video on mechanisms as well. Okay, okay, Chandan, fine. Okay, I understood, Varshu. So yes, I'll be coming with a video where I'll be taking all the 5 marker questions. So you know we have started a PU2 session, right? So where we are giving you 1 marker, 2 plus 3 marker and 5 marker. And in 5 marker we chemistry have only organic chemistry questions. So I'll be bringing all the different questions. Okay. Yes, Varshu, it will be done. Anime addicts, game over. Yes, dear, game. The session is already over. So I'm waiting for your comments. Okay, Pradeep, that is really meaningful for me. Okay, so I also want to suggest all of you one thing. You have seen that in DNF block one part is there, the properties, the trends, okay, and that many students find difficult. So in that KSET 60 out of 60 series, okay, DNF block part 2. Okay, so please do watch that. If you have problem in this, all your doubts will be clarified. So it is not, I am not saying, it is like my old students who were in my different, when I was teaching my, I can say the students whom I taught before, they are now in 12th and they watched that video and they really appreciated that these concepts, it is very easy to understand from the electrode potential, the oxidation states, right? That all things were little confusing, but yes, I have tried the best to explain it. So please, if you have any doubt in that, you can watch that. Yes. Yes, Pradeep, you can definitely expect, sorry, not Pradeep, Kannadiga, you can expect similar questions in the exam. Yes, Srinivas, if you have applied in KSET for NEET counseling, can I write KSET exam? Yes, dear, definitely you can write KSET exam, but if you are writing NEET exam, you also need to register for KSET. Chandan, for organic chemistry, please do reaction mechanisms. Okay, reactions, you have to do flowcharts of the reactions, and day and night you have to sit and see that reaction mechanism. And to master your reaction mechanism, the best way is to solve conversion questions. That is what my teacher used to tell me when I was in 12th. He used to give us homework 15-20 conversion questions, okay, and he used to give us a flowchart of the organic reactions. So we have to see that flowchart and we have to solve the questions. So by solving so many conversion questions, all the reactions were in our mind, all the name reactions were so easily we have remembered. So that is what I suggest to my students. So you can also do that. Salman, next class will be on Monday. Anime Addicts KSET hall ticket is not yet out. It will be out after when the exam is near. It is not yet out. So you will be getting in the KEA portal only. Srinivas, ma'am, can I get engineering rank if I applied for medical Ayush in KSET application form? No, Srinivas, you have to apply for engineering, then only you will get engineering. Shreya S, tricks for organic chemistry. Yes, dear, this is the trick that I followed. Please do not mug up the reactions. Understand it and try to solve conversion questions. If you solve more and more conversion questions, then definitely you can remember more reactions. Okay. Yes, Pradeep is definitely definitely correct here. Chemistry 60 plus strategy video, ma'am. So SR Kannadiga, that is already there in our channel. I will tell you 6 chapters. Do these 6 chapters properly. Solutions, kinetics, D and F block, haloalkanes, alcohols. Okay, sorry, haloalkanes, alcohols, and which one? I forgot. Aldehydes, ketones and carboxylic acid. These 6 chapters you do, you will definitely get 58 plus 60 plus you can get. To be on the safer side, do one more chapter, that is biomolecules. Okay. No, Srinivas, you cannot get engineering rank. IDK, do not worry, once the board is over, we will be coming up with videos, will be coming up strategies, will be giving you everything. So do not worry, now please focus on board, and everyone's target should be 290 plus in your board examination in PCM. All of my students should target for 290 plus, and I want chemistry, you should be the one you are doing best. Okay. Yes. Srinivas ma'am, I should remove the medical counseling in KSET application and have applied for PCMB. Please reply. Srinivas, you can select both PCM, you can select medical, you can select engineering courses as well. Okay. Diksha, okay. Ma'am, I am facing difficulties in aldehydes chapter. I know, dear, that is a little bit lengthy chapter, but what you can do is, as I told you, please, you just watch my KSET 60 out of 60 aldehydes chapter and just draw the flow charts. Okay, draw the flow charts there and keep it and keep revising the flow charts again and again. Yes, Kannadiga, 2 and 3 markers important question video chemistry is already out, and those type of questions will be asked, so please prepare those questions. Yes, Mohammed, if you watch the 2 and 3 markers, then definitely most of the questions you will be able to solve. Okay. Okay, students, that's all. Now please go back to your studies. Remember, last 6 days, last countdown, last time to put 100% of your efforts, right? So I want all of you to not waste even a single minute, single second. From today onwards, 8 to 10 hours of self-study with full focus is very, very important. Any help you require, do let me know. I will definitely do it for you. Okay. So now, Shreya S, ma'am, can we skip aldehydes? Shreya, see, aldehydes you will be getting 2 5-marker questions from aldehydes, right? So total 10 marks will be coming. So if you do other 4 chapters properly, haloalkanes, alcohols, amines and biomolecules, if you do these 4 chapters completely, because there will be 6 questions in the 5-marker section, that is your section D. 6 questions will be there, you have to attempt any 4, and 2 will be from aldehydes, ketones and carboxylic acid. So if you do the rest 4 properly, then I can say you can skip, but yes, then you will lose marks definitely in MCQs. Okay, so 2 MCQs will be go if you are mixing the this one. Okay, I hope I have answered all your questions. So yes, students, bye bye, take care, and really all the best. I wish you all the best. Please, anything, please do put down in the comment sections. I'm always watching your comments, trying to reply most of them, but yes, no, nowadays we're little busy with the content and all. Many of your comments I have been not replied, but yes, do not worry, Saturday, Sunday is coming. I will reply to all of your comments. I'll see to all of your comments, so you can put down now. Okay. So yes, bye bye students, and all of you have a good weekend, have a very hard working weekend. Okay, chalo, bye, see you soon in the Monday class. Okay, DNF block will be doing there. Okay, tada. Yes.